All right, now we start to think about this pitch change because of the Doppler effect. We got to talk about things that are moving and things that are moving relative to us. But let's first imagine that we're not moving, that things are stationary. So what I'm going to do here is we're going to have a source of sound. All right, this source might be a siren from a police car or ambulance. It could be somebody shouting. It could be any type of noise that's being generated. Now, as that noise is generated, isn't there a wave pulse being sent out? Remember, it's a longitudinal wave, and that pulse travels through the air like so, and then, say, ends up in this spot. Now, we could put a person here, pick your favorite student, and when we listen, we hear that sound as it hits us at that spot, point in time. All right, when we take a look at that, we've got a certain distance between each wave. So what I'm drawing here is the tops of the waves as they go through. So it would be like, here's the first one, there's that one when it arrives there, when that one arrives there. So this curve right here is actually the wave itself. And the space between the waves is called the wavelength of the thing. All right, so if we think about that, all right, we've got ourselves a nice little source of sound putting out waves at some frequency. How frequent? You know, a siren could end up being maybe 1,000 hertz. So we're making these waves 1,000 times a second, and those are the ones that we associate, say, with a police car or some type of ambulance. All right, now if we think about the amount of time it takes to travel between here and here, all right, we know that distance is equal to the velocity times the time. All right, and the distance here is actually, the spacing between here and here is actually the wavelength. The velocity is the speed of the velocity of the sound itself, we'll call that v. And then the time, if we think about, is not just any time, isn't it the time between making the sound? So, do you remember the swing lab? Then we actually figure out the time. It's not just any time, isn't it the period, the time it takes between the waves? So when we actually did that on Data Studio, we actually measured the time difference between these and then calculated the period. So this is not just the any time here, this is the period. So if we take this and then solve that, the period is going to be equal to the distance, which is the wavelength, divided by the velocity of the sound itself. And that tells us how much time it takes or what the period is for this particular wave. All right, now,